We are going to have an overview of automotive industry and the rise in complexity and the cost factors that comes up with automotive industry, and what are the software development demands are there in the automotive industry for today. The ECU development cost. We all know that the engines, the body parts, and the other things form the crux of a car is what we all know. But there is something beyond it. The ECUs and the other sensors and actuators and the other things which forms the crux and core of it. So we are going to have a look at what are the development costs and how to reduce them, and what are the various ways with which we can reduce them. That we are going to have a look at it. The software reliability demands, we are going to have a look at it. And after covering all these topics, what model-based development can do here, how a different model-based development is this, and how a model-based development is going to support the development of embedded software, how it is going, I mean, what were the traditional techniques, what were the disadvantages associated with the traditional techniques, how model-based design is a much simpler approach to an existing problem, and how it can take things forward. So that is the base of it. And on top of that, the model-based design can be worked across a lot of different applications. Like if you're going to work on the powertrain design or software development for it, a model-based development and design approach can do there. But today, what we are going to have is, like, we're going to see about ADAS and AUTOSAR role. So this is going to be an introductory class on the model-based development, ADAS and AUTOSAR. I kindly request the students to make note of their doubts, and towards the end of the session, we can discuss them basically. Yes, and again, the most important point comes at last. What are the industry demands for an MBD engineer? So my vision for the complete course is something like this. If there are students or engineers who would like to take up the session, the complete session, at the end of the session, you should be trained well enough to understand the concept, to have a hands-on experience on the model-based design concepts. You would be able to have hands-on experience of at least one or two ADAS functions, and what is AUTOSAR and other related things based on that. So that's the complete thing. So that's the whole motto that I have for this session. So I'm moving on to the next slide. So as discussed, it's going to be the overview of automotive industry. So it's like this. Okay, for people who are from non-automotive background, all that they know is, like, there are millions of cars that is running in the world, and you would have seen in newspaper about Hyundai launching Kona. So there is a demand for automatic cars coming into picture. Tesla is working on it. Hyundai in India have started production, and they're also going to start sales of Hyundai Kona, which is a complete EV powertrain. So there is a huge demand and supply of the automotive industry, I mean of the cars in the world. So you can actually see here, there is a nearly 7 crore cars, which is like 70 million cars that is being produced in the world, that was produced in the world last year, and we have close to 4 million cars being produced annually in India. So we have huge number of cars being produced. So if you can see the car manufacturing laborers, okay, there are people who sit in the plant who do the mechanical job, and there is not only mechanics that is involved in the production of car. Okay, there is also another side. There is a side of design. Okay, you send a sheet metal, the sheet metal is going to come out as a car. There are certain set of engineers called CAD, CAE, and other engineers who spend hours on the design and deployment and stuff. So that is one part, I would say, of the skill set that is needed from engineers in automotive industry. So coming back to the original point here, there are huge number of cars being produced all over the world. This is only about the cars that I'm talking. I'm not talking about the buses or any other 4-wheel or 6-wheel things here. So there is a huge demand, or huge supply is there, but are there enough engineers, skilled technicians is the right word here, to satisfy the demands of the industry. So that is a very, very important thing. So in automotive industry is concerned, who does what here? Okay, we have someone called as the OEMs. Okay, the OEMs as an expanded as original equipment manufacturer. They are the car manufacturer. Say someone like a General Motors, a Nissan, a Honda, a Porsche, a Tata. These guys are all OEMs. They sell car. They sell it as a package, as a car. They sell it outside. Okay, the next stage is the ECU suppliers. Okay, the car has an engine, a lot of sensors. To control those sensors, you need an electronic control unit with the right software flashed into it. Okay, so the ECU suppliers are those people who generally involve in development of software as per the system requirement, flash them into the ECU and give it to the OEMs, where the OEMs will connect this ECU with the powertrain unit or with any other unit of the car, and the car starts running. Before that, there are a lot of stages that is involved with a lot of software design, development, testing, etc., which we will discuss in brief, at least on what that is over the course of this presentation. And the last stage is like we have a lot of, it's not merely about the OEMs and the suppliers here. There are a lot of other stakeholders that are involved, probably in tier 2 people, someone like the tool developers, they are involved, because you need the softwares to be developed at a much faster rate. The developed software can't be tested in a car every time around, because there is going to be huge cost that is involved, and it's a huge laborious time consuming process as well. So you need a lot of software testers, or the tools need to be developed in order to test these softwares. So here comes some tier 2 level suppliers, like people like MATLAB and people like BTC, Reactus, etc. Those people are involved in development of tools which help us test these engine softwares, basically, or which help us in develop the models and designs to test these softwares, basically. So this is the hierarchy that is involved, and all the three partners here, the OEMs, the ECU suppliers, and the tier 2 suppliers have interactions, the from and the go and through interactions at different stages here, basically. So this slide has a basic information on what a modern automotive system looks like. You have all these new high-end cars that is coming in the market these days. If you have a look at these cars, so this, it's not just a car with a seat, a steering wheel, 4 doors. It's no more like that. It's more on a very interactive. It's built on a very, very smart level. So that's the whole thing is about. It has made the process of driving a lot more easier these days. Okay, back then in 1950s, we would have a car which would not necessarily have a roof. It does not have a power steering of today's. It does not have any music system or interactive system. Like 30 years back, we had cars only with a fitted music player or something where we can throw in cassettes to play. It had no other support. It did not have a power steering. Everything was like, it made the job of a driver very laborious. But in today's market, considering the competition level that is there among the different companies, the growing population, the growing demand of the people to say, I am very bored of driving, sitting in a seat driving, I have to take care of a lot of things. What if I suddenly get a phone call? I have to put the phone into my pocket, or I have to like stop my vehicle somewhere and do. So these are all laborious process. So considering all these constraints in today's life, the OEMs and the tier 1 suppliers have made the car a lot more interactive, intuitive, and a smart system. In today's smart system, the car must be able to take care of the things by itself. The car must make your drivability a lot more easier, actually, and it must make your job a lot more simpler. I mean, the ultimate thing what an OEM looks at is like a driver must enjoy the experience of driving. The passengers must enjoy the experience of traveling in their car. That's what they look at. Back 20 years back, something like a blind spot detection, or in the cars of 1990s, there was no rear camera. The cars of 2000s had rear camera. The cars of 2010s and 2020, it's having automatic cruise control, a wrong way alert, and these are all smart systems that have come. The power window control, etc., etc. So these were not there as advancements 20 years back. Today, in the steering column, you have buttons where you click on one button, you can talk to people. Back then, you have to stop your car, ask for route, and then you have to go. Okay, now today's cars have GPS. Not, they don't only rely on your mobile GPS. You can actually connect your mobile to a display screen, a touch screen. You have cars which are sold at 4 lakhs, 4.5 lakhs in India, which has this touch screen and which is run on either Android or Apple iOS. Okay, so such huge that the market has grown into so much things that they actually give it to the customers. And to develop a lot of these things, we need skilled and trained technicians. And how quickly a person is learning and he's able to demonstrate the skills, that person is more, I mean, he has a lot of opportunities, better opportunities to get his job. So that's the whole thing about here. So this is what I was talking about. Okay, it's just an extension. So the first automotive ECU, it was like one ECU is connected to a General Motors car in the year 1977. And then in 1981, General Motors was using a car with a 50,000 line of code. So the complete car, that is the powertrain unit or the infotainment, comfort level, etc., etc., whatever features that that car had, the entire line of code that was there is only like 50,000. But you come to today's cars, okay, there are very small level microprocessors and microcontrollers to a big ECUs. There are a single car in India, I would say, has like 3 or 4 ECUs. I'm not talking about high-end cars. I'm talking about a Maruti Alto kind of a car, which is a budget car. Those kind of cars have probably 3 or 4 ECU. They have like a few tens and hundreds of sensors and actuators and motors which are connected to it, and like huge number of wiring harnesses go here and there. And on top of that, to control the harnesses, motors and other stuff, etc., etc., you are writing millions of lines of code. Today, premium class automobiles have close to 100 million lines of code that is being written. This 100 million lines of code, whatever that a person is writing, goes into one single car. Imagine the number of cars that is being produced, different variants of cars that is being produced, and it's not just in India, I'm talking on a global scale. So just imagine how the amount of effort that goes over here, the level of demand that the industry is actually talking about here today. Okay, so what are the challenges in today's market? Okay, so all that we have seen, we have huge number of cars being produced in the world. What are the different electrical and electronic advancements that we talk about with the car today, and how things are basically. So we all know that in the previous slides we have all seen, we have huge number of cars being made. We have a huge software related, electrical and electronical related upfront in the vehicle manufacturer and the other things that is happening over here. So what next? So what are the risk factors that is involved here? And you need to compete your rival to push your car front in the market. So you're working on a feature, your rival is working on a very similar feature. So who's going to push the car first to the market? So you also must take care of things like safety, the software quality, and it must be a good quality software. The feature must be pretty new. I mean, it should be developed quickly. It should be tested, validated quickly, and all that. Because at the last stage, if you're going to drag your time to develop a software and push it into a car and test it and take it to the market, and if someone else is doing it in a much quicker way, obviously that car is going, your rival's car is actually going to get a better business, which we all do not want, basically. So this is what the people are looking at. So when you're looking at the challenges in today's automotive market, like any other market, it's like there is a lot of risk that is involved, the time to market related issues are there. The risk as in we are talking about is the damage, reputation, recall, and the time drag that happens over there. Damage is like when you're trying to develop a software, say, okay, there is something like there are a lot of electronics that is being used, sir. Okay, so I need to now write softwares. So what if your software is not foolproof? We all can make mistakes, right? You're going to write a software with 100 million lines of code. So there is a good enough chance that there is going to be a mistake here and there. What if you're doing it manually? What is the damage that it is going to cost? You're doing it manually. You did not trace it anywhere. You have flashed it into your ECU and your car has gone to production. And when you're trying to diagnose it at the final stage, and if you get an issue, it's going to be a huge cost that is involved. You have to stop the production of all the cars right there. We have heard of news like that. A lot of news has actually come in the market. Like recently, one of the cars, one of the American manufacturers' car, I don't want to name the OEM actually, they have called back a lot of their cars. Okay, so such issues are actually there. So once you're trying to recall the cars which is already sold in the market, there is a lot of reputation related issues. Recently there was another news last year. This comes from a French car manufacturer. They said that they have an automatic transmission vehicle and they're trying to push the car up a slope. The car is not actually going, it is rolling back. See, I mean, they try to test the car in a place where there is no one. They do it. If issue is detected, it's fine. But this happened at the production stage. The car was manufactured. It went through. They did not experience this issue when they were testing at their foregrounds. But when the people started using it in competitive market, they found it out and they recalled almost 25,000 cars. This happened right in India. So these are the problems that is there. Once you have incurred a huge cost related issue there, the OEM's reputation, these guys are in the market like for 100, 150 years. Okay, people have developed a lot of trust in them to go and buy these cars. So these are like huge amount of things. There's a lot of time waste when you're trying to look at a car that is a lot of, if you guys are going to go into automotive industry, you would be put into a project where you'll be working on car related projects where the car is going to come to market only in 2021 or 22. So you are investing a huge amount of time there. So there is a lot of time waste, there is a lot of reputation, and a lot of things go for a toss. So when you look at these things, this is the problem here ideally. This is what we have to look at. So these are the basic challenges in the market. So as I have already said, the quality, cost, the calibration, when you're trying to put your car across multiple variants, you would have known in the market, say something like the Hyundai Santro is there. Santro is not one car. I mean, it's technically one car, but it has 5 or 6 different variants. You have a petrol, you have a diesel, you have 3 different variants in petrol, 3 different variants in diesel, and on top of that, you have an automatic transmission versions for them as well. So basically, it's one single car with 9 different variants. So each variant has its own differences where you have to give the right software to the right variant. So you can't sit and write, say you're writing a manual code for a certain operation. This is different for one variant and the other. You can't completely copy paste the code and make the changes. You are prone to make a lot of human errors. So the biggest challenge is like, how can you automate or how can you fasten the complete process of software development such that whatever code that you write, which is going to be flashed into an electronic control unit, must be foolproof, must be correct. It must the whole process of design, verification, and others must happen in a very, very small amount of time, and it must reach the customers quickly. When customers tomorrow are coming up with any issues, you must be able to debug and you must be able to provide a solution much faster than the rest. So one of the solutions that is being discussed and that is being seen in the industry is like you can improve the design and architecture part. That is one. The next one is like parallel software development that they are asking. And one of the things that is also being discussed is like multi-core ECU. Previously in cars like 10 years back, there was only like one electronic control unit. Now you have 3 or 4 ECUs for different variants, and all these ECUs are not single core processors, they are multi-cores. Okay. something like that. So these are some of the key solutions, and one of the more popular solutions as far as software development, ECU software development is concerned, is like model-based development. So this is the crux of our presentation today. So we have seen what are the demands of automotive industry here. We have seen what are the challenges in developing automotive industry software,